Let's continue our discussion about writing by talking about what does a good paper look like. First, let's begin with the simple stuff. Follow the rule. You should submit your paper by the deadline. Many groups have internal deadlines. These are just as important as external deadlines. And follow the rules of whatever venue you're submitting to. Look at the call for papers, and they usually have a sample submission. Read that carefully. It's not just a document that you delete all their stuff and put your stuff in. The stuff that was there in that sample document tells you how to format your document. Follow those rules. If you submit to a place long enough, you will learn and internalize those rules, but your first couple of times, look at it, read through it. It will tell you, here's how you should format a caption. Here's how you should format a table. Follow those rules. Many of your simple questions will be answered there. Don't tweak the layout. If you're short on space, edit the text. Don't do VSpace hacks. That can get your paper desk rejected. Sometimes you'll squeak by, but it's a bad habit to get into, and you should focus on editing the text rather than trying to cheat the layout. Many of us work on software where we have things like continuous integration for our compilation. You should use the same process for writing your paper. Have processes that check whether all of your references are defined, whether you have spelling errors. Our group has a style checker. Neil Spring from the University of Maryland has created a number of tools, Ruby scripts that help you check whether your paper has style errors or not, that talk about many of the rules that we talked about before. So you can run these as continuous integration scripts, check to make sure that everything is going okay, especially when you get near the deadline and say you have 5 people writing a paper, errors pop up. And if you have these tools that can catch those errors, you can save yourself embarrassment. Make sure that your paper looks good. Make a good first impression. Many people will skim a paper before reading it. And so like they open up the tab on archive, they see your paper, and am I going to read this or not? Oh, this looks kind of messy. And then maybe they download it, never read it. Maybe they just close the tab without looking further. You only have one chance to make a good first impression. So make sure that things look good. Aid skimming. So maybe someone won't read your paper at first, they'll just skim it, but make it easier for them to skim. Make all the figures self-contained. Every caption should have a takeaway. Why is this figure here? What is it telling the reader? Don't just say, summary of our results. Talk about why your results are important. To test whether our fancy pants algorithm succeeds at better segmenting Chinese text, we evaluate blah, blah, blah. Make the figures consistent, readable, and attractive. Like, it should be obvious that these figures belong in the same paper. Don't generate one figure in Excel, one figure on Google Sheets, and another figure in ggplot2. They should look like they belong together. Make them attractive. People often create figures and then scrunch them down at the last minute so that they're barely readable and you need to zoom in on the PDF. Don't do that. Color is good, but at the same time, it shouldn't be necessary for understanding the figure. Some people are colorblind. Some people review papers with black and white printers. Use color, but don't depend on it. One kind of controversial piece of advice that I would like to give is that the related work should come later than a lot of people do. And here's a typical organization for a standard computer science conference paper. The related work shouldn't come at the beginning of the paper. The related work shouldn't stand between your idea and the reader. Someone reading the paper has budgeted a certain amount of time to skim the paper to get to the idea. If you bog them down in related work, it will take longer for them to get to your idea. And that's the real point of a paper in the first place. What you can talk about is the essential prior work that is necessary for understanding your idea and giving credit. And so this goes back to the citation rules that we talked about before. Cite generously, cite the things that are relevant, but talk about how that specifically relates to your idea and do the bare minimum first. Later, explicitly write the related work about all of the things that are relevant. You should also have evidence and interconnection between the ideas in your paper. The introduction will make claims. Check that each claim is supported by evidence later in the paper, in the results section. This is a good opportunity for forward pointing. And so you can talk about all the claims that you make in the introduction and point to the relevant sections that do this. And this is a lot better than doing things like Section 2 introduces a problem, Section 3 talks about our method, Section 4 evaluates our method, finally Section 8 concludes. That could be in any paper. Any sentence that could be in more than 5 papers doesn't belong in your paper. This is just a single lecture from a course. YouTube likes to show you these videos out of order, but if you go to the course webpage linked below, you can see the lectures in the right order, and you can get resources like homeworks or suggested reading. You can also visit quanta.org if you want to learn about our systems for creating computers that can answer questions, where Quanta stands for question answering is not a trivial activity. If you want to help the channel, provide a big gradient to the algorithm by liking and subscribing.